Hello students, welcome to Swara Sir's classes. In this video, we will talk about analysis of variance. Now, in two-way analysis of variance, we consider data that are arising out of an experiment, in which the effects of different levels of two factors on a response variable are studied in a single experiment. So here the data are being considered that are coming out of an experiment in which the effects of different levels of two factors on a response variable are studied in a single experiment. So this data, it is presented in a two-way layout. With each factor representing one direction. So if factor A is representing the horizontal direction, then factor B will represent the vertical one. So the data is being presented in a two-way layout in which each factor is being represented by one direction. Now it is possible that one factor is the main interest. Suppose A is the main interest, and the other factor, it though affect the response, but it is not the actual concern of experiment. So it though affect the response, it is not the actual concern of experimenter. So it is not the actual concern of the experimenter. In such situation, these factors are called nuisance factor. And if such nuisance factor, if they are unknown and uncontrollable, so if they are unknown and uncontrollable, then randomization technique is adopted. And if it is known and controllable, so if this nuisance factor, it is known and controllable, then blocking technique is used to eliminate the effect of this nuisance factor on the response. So if this nuisance factor, that is the factor which affect the response but it is not the actual concern of the experimenter, if this nuisance factor is unknown and uncontrollable, then randomization technique is adopted, and if it is known and controllable, then blocking technique is adopted to control or to eliminate the effect of the nuisance factor on the response. Now suppose we have the following model: Yij, it is equals to mu ij plus epsilon ij, where epsilon ij is the error term. Now suppose there are two factors, factor A and factor B, that are affecting the response. So suppose this factor A has k different levels. So factor A has k different levels and factor B has L levels. Now suppose this factor A, it is our factor of interest. So it is our factor of interest, and this factor B is the nuisance factor. That has n blocks, L blocks. So factor A, which is our factor of interest, it has k different levels, and this experiment is run in L blocks. That is the other factor, that is factor B or the nuisance factor, it has L levels. Then we can write our Yij is equals to mu plus tau I plus beta j plus epsilon ij, where our I would run from 1 to so on till k, and j would run from 1 to so on till L. So here this mu, it is the overall effect present in all observations. It is the overall effect that is present in all observations. This tau I, it is the effect of ith level of factor A. It is the effect of ith level of factor A, and this beta j, it is the effect of jth level of factor B, that is our nuisance factor. So it is the jth level of factor B, and this epsilon ij, as I said, it is the error term or random error. Now here we assume that these epsilon ij's, they are independent and normally distributed. So they are independent and normally distributed, and they are normally distributed with mean 0 and variance sigma square. So this epsilon ij, they are independent and follows normal distribution, that is they are normally distributed with mean 0 and constant variance of sigma square. Then this model, so let us denote it with equation number 1. Then this equation number 1, it is the effect model. So this equation number 1, it is the effect model. So this Eij, which is the error term, it follows normal distribution with mean 0 and variance, constant variance sigma square, and these Eij's, they are also assumed to be independent. Now, just as in one-way Anova model, we usually define this Ti or tau I is equals to mu I naught minus mu, and beta j is equals to mu naught j minus mu. Now here we are considering that the factors are fixed factors. So tau I is equals to mu I naught minus mu, and beta j is equals to mu naught j minus mu, where this mu I naught, this is equals to 1 by L into summation j runs from 1 to L mu ij, where our I, it runs from 1 to k, and similarly this mu naught j, it is written as, it is equals to 1 by k into summation I is equals to 1 to k mu ij, where our j, it goes from 1 to L. So we have our mu I naught is equals to 1 by L summation j runs from 1 to L mu I j, where our I runs from 1 to k, and mu naught j is equals to summation 1 by k into summation I runs from 1 to k mu I j, where our j runs from 1 to L. And our mu it would be equals to 1 by k summation I runs from 1 to k mu I naught, which is equals to 1 by L summation j runs from 1 to L mu naught j. So this mu it is either equals to 1 by k into summation I runs from 1 to k mu I naught, or it is equals to 1 by L summation j runs from 1 to L mu naught j. So summation I runs from 1 to k tau I it is equals to 0, and similarly summation j is equals to 1 to L beta j, this is also equals to 0. So we have our tau I it is equals to mu I naught minus mu, where this mu I naught it is equals to 1 by L summation j runs from 1 to L mu I j, and mu is equals to 1 by k summation I runs from 1 to k mu I naught. So if we here our I would run from 1 to k, so if we have a summation on both the sides, then we will get summation I runs from 1 to k tau I it would be equals to summation I runs from 1 to k mu I naught minus mu. Now since mu is the mean for mu I naught, so therefore this deviation, the sum of deviation it is equals to 0. So we get summation I is equals to 1 to k tau I is equals to 0. Similarly, so our beta j it is equals to summation mu naught j minus mu, where this mu naught j is equals to 1 by k summation I runs from 1 to k mu I j, where our j would run from 1 to L, and our mu would be equals to 1 by L summation j runs from 1 to L mu naught j. So if we take summation on both the sides, we will get summation j runs from 1 to L beta j, this is equals to summation j runs from 1 to L mu naught j minus mu. Similarly, since mu is the mean for mu naught j, so it is the sum of deviations which is always equals to 0. So we get our summation j runs from 1 to L beta j also equals to 0.